Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET JEE-Main, we're going to be looking at some questions asked in previous year's exams for medical and engineering entrance. So we're going to be looking at some questions of physics asked in medical and engineering entrance exams in India, and today the chapter that we're dealing with is moving charges and magnetism. Now this chapter of physics is listed as the fourth chapter in the grade 12 syllabus for CBSE. So there are a lot of questions from this chapter, and let's look at some of them which were asked very recently. Here lies question number 1. A charged particle is moving along the electric field as shown in the figure. What is the horizontal displacement of the charged particle when it descends a distance of y? So as you can see, the particle is undergoing a parabolic path, and so therefore we need to find out the horizontal displacement when it descends a distance of y. And we know that Q by m is given as 9.6 into 10 raised to 7 coulomb per kg. E is 5 into 10 raised to 5 volts per meter. Y is 84 centimeters, and G is 10 meters per second squared. So, how do we solve this question? So, the first thing to note is that particle descends a distance of y. And so, over here, we can apply the second law of motion, which states that the displacement is equal to half times gt squared, where g is the acceleration and t is the time period. So from this equation you'll get t squared as equal to 2y by g. That means t equals 2y by g, which is present inside a root, inside a square root. Now for the x-axis, we again use the same formula. X, that is the displacement, equals half acceleration along x times t squared. Now acceleration here can be written down as QE divided by m, where Q by m is the charge per mass and E is the potential per meter. And we also know the formula for t squared as 2y by g, so therefore we can write down x as equal to half times ax, which is QE by m, times 2y divided by g. So let's plug in the values. Half times q by m is 9.6 into 10 raised to 7. Then you have E, that is 5 into 10 raised to 5. And after that you have 2 times y, the vertical displacement. And we know that the vertical displacement is 84 centimeters, that is given. So 84 centimeters, that means 84 into 10 raised to minus 2 meters. And then divided by g, where g is 10 meters per second squared, so just divide by 10. So now what we're going to get is, 2 gets cancelled out. Then you have 9.6 into 5 into 84. And then you have 10 raised to 7 plus 5 minus 2 minus 1. So therefore you will get 96 into 5 into 84 times 10 raised to 7 plus 5 plus 1 minus 3. So therefore x is now equal to 96 times 5 times 84 times 10 raised to 9. So as you can see, 7 plus 5 is 12, plus 1 gives you 13, minus 3 gives you 10, so it's times 10 raised to 10. So 96 times 5. 6 times 5 gives you 30. 9 times 5 is 45. 45 plus 3 is 48. 480 times 84. 0 times 4 is 0. 8 times 4 is 32. 4 times 4 is 16. 16 plus 3 is 19. 0 times 8 is 0. 8 times 8 is 64. And 4 times 8 is 32. Plus 6 gives you 38. So then when you add these two, you get 0, and then 2, and then 13. So 1 goes to the other side. 1 plus 1 gives you 2, plus 8 gives you 10. 1 goes to the other side here, so that's 4. So now x equals 40320 times 10 raised to 10. Now, if you look at our options, you can see that most of these answers are in the range of 4.03. So now you can cancel out option D, 8.06, because that's not there. So then you can write 403.2 into 10 raised to 8 meters as the correct answer. So therefore, if you are looking for the correct option, then the correct option here is option A, 403 into 10 raised to 8 meters. Now that was the first question which was asked in 2018. Let's look at another one. A galvanometer of resistance 100 ohms is converted to a voltmeter of range 10 volts by connecting a resistance of 10 kilo ohms. You need to find out the resistance required to convert the same galvanometer to an ammeter of range 1 ampere. So we have setting of a voltmeter. Voltmeter has the resistance connected in series, and ammeter has the resistance connected parallel to it, so it's a shunt resistance. So now we know that the range of voltmeter is 10 volts, and we also know that the galvanometer resistance is 100 ohms, which we can write as 0.1 kilo ohms, because the resistance that is given in series is, 10 kilo ohms. So now we need to find out the current here. So V equals Ig times G plus R. So Ig equals, V, that is 10 volts, divided by G plus R. So that is 10.1. So approximately you get the value of Ig as 1 milliamperes, which is 10 raised to minus 3 amperes. So this is the value of the resistance of the galvanometer. Now, for the second case, that means to create an ammeter, the current that is passing through the shunt resistance times the shunt resistance is equal to the current passing through the galvanometer times the resistance of the galvanometer. So from here you get S, that is the shunt resistance, as equal to Ig times the resistance of the galvanometer divided by I minus Ig. So here in this case you can write Ig as 1 milliampere, that is 10 raised to minus 3 amperes, and then the resistance of the galvanometer is 100 ohms. Divide that by I minus Ig. I, which is the range of the ammeter, is 1 amperes, and then minus Ig, that is 1 into 10 raised to minus 3 amperes. So therefore, in the numerator, you get 10 raised to minus 3 times 100, so that is 10 raised to minus 1, divided by 1 minus 0.001. So you get 1 divided by, so 10 raised to minus 1 can be written down as 0.1. So 0.1 times, divided by, so you get 0.999. and you can write this down as 0.1 into 1000 divided by 999. So basically 0.999 is 999 divided by 1000, but since that's in the denominator, it was shot up to the numerator. So now you get 100 divided by 999 as the value of the shunt resistance. So when you do that, 100 divided by 999. So as you can see, 100 doesn't go in 999, so therefore you have 0. And then when you put a point, you get 1000. So after getting 1000, you know that 999 goes into 1000 one time, so you put 1. And then the remainder is 1. And then you need to put in, two other zeros before putting a 1. So 0.1001001 would be the correct answer. And so we can approximate it to 0.1 ohms. So the value of the shunt resistance is less, and the value of that resistance is given to be 0.1 ohms. So among the following options, you can say that option D, 0.1 ohms, is the correct answer for this question, which was asked again in 2018. Now let's look at a different question. A long cylindrical wire carrying a current of 10 amperes has a radius of 5 millimeter. Then find its magnetic field induction at a point 2 millimeters from the center of the wire. Note that the current here is uniformly distributed. So the radius is 5 millimeters, that is 5 into 10 raised to minus 3 meters, and and then you have the small r, that is the distance, that is given to be 2 millimeters, which is 2 into 10 raised to minus 3 meters. So therefore we know the value of the radius of the wire. We also know the value of the distance from the center of the wire, and we know the value of current here, which is 10 amperes. So we need to find the value of magnetic field induction. So that is B equals mu naught IR divided by 2 pi times capital R squared. So mu naught, the value of mu naught, that is permeability in free space, is 4 pi into 10 raised to minus 7. Then you have 10, and small r is 2 into 10 raised to minus 3 divided by 2 pi times 5 into 10 raised to minus 3, the whole squared. So pi gets cancelled. 2 goes into 4 twice. 2 times 2 times 10 gives you 40. And then 5 squared is 25. So 40 times 10 raised to minus 7 minus 3 gives you 10 raised to minus 10. And in the denominator, minus 3 the whole square gives you minus 3 times 2 gives you minus 6. So 25 times 10 raised to minus 6. So let's write that again. B is 40 into 10 raised to minus 10 divided by 25 into 10 raised to minus 6. So 40 by 25, when you divide both the numerator and denominator by 5, you get 8 divided by 5. And the power would become 10 raised to minus 10 plus 6. So when you look at 8 divided by 5, you have 1. 8 minus 5 gives you 3. And then you put a point, it becomes 30. And then you put a 6. So 6 times 5 is 30. 30 minus 30 is 0. So 8 divided by 5 is 1.6. 10 raised to minus 10 plus 6 gives you 10 raised to minus 4. So the value of B is 1.6 into 10 raised to minus 4 Tesla. Tesla is the unit of the magnetic field induction. So if you look at our following options, you can see that option A, 1.6 into 10 raised to minus 4, is the correct answer. Now let's look at the final question of this episode. This question was asked in 2017. And the question goes like this. Let's put in the pointer there, 2017. A square loop ABCD carrying a current I2 is placed near to and is coplanar with a long straight conductor XY carrying a current I1, which is shown in this figure. You need to find out the net force present on this loop. So as you can see, you can consider the arms of the loop as a straight conductor, and so therefore this question would involve the force acting between the two parallel conductors. Now, conductors BC and AD do not match, do not interfere in this question because their magnetic fields and the magnetic field of XY are perpendicular, so they do not exert any force that is sufficient to change values. But then AB and CD are the main players in this, question, so let's start with them. Now, if you look at the following diagram, you can see that the current passing through AB is on the same direction as that passing through XY. So I2 here is passing in the same direction as I1. So both of them are going to have counterclockwise loops of magnetic field. And as you can see, in this scenario, the loop coming out of AB is being pushed with the loop coming out of XY, and they are in opposite directions, so therefore there is a repulsion. So arm AB is repulsed by the current I1. So therefore the force acting on the arm AB can be written down as mu naught by 4 pi times 2 I1 I2 L, which here is the length of the second conductor, divided by L by 2, where L by 2 here is the distance between the conductor and the arm of the loop. So, this 2 goes up, 2 times 2 gives you 4, 4 cancels out with 4, so you have mu naught I1 I2 divided by pi. The L in the denominator cancels out with the L in the numerator. So the force acting along AB is mu naught I1 I2 divided by pi. Now let's look at the other arm in question, which is arm CD. As you can see, in arm CD, the current I2 is flowing in the opposite direction as that of XY. So therefore, here the current's direction changes, and since the current's direction is now, opposite to that of XY, so it creates the effect of the opposite pole. So therefore, since opposites attract in magnetism, so XY gets attracted to CD. But then over here, the distance is L plus L by 2, which gives you a total of 3L divided by 2. So the distance between the arm CD and the conductor XY is 3L by 2, and the length of CD is L. So we can write that arm CD is attracted by the current I1. So therefore, the force along CD can be written down as mu naught divided by 4 pi times 2 I1 I2 L divided by 3L by 2. So this 2 goes up again, so that becomes 2 times 2, 4. 4 cancels out with 4 here, and then L cancels out with L here, so you have mu naught I1 I2 divided by 3 pi. So this is the force along CD. So now we need to find out the F net. Net force here is FAB minus FCD. It has to be the difference because FAB is greater than FCD if you look at it. So as you can see, mu naught I1 I2 divided by pi, these terms are common in both the forces. So the difference would be 1 minus 1 by 3. So therefore you get 2 by 3 times mu naught I1 I2 divided by pi. So the net force in this question is 2 mu naught I1 I2 divided by 3 pi. So if you look at the following options, you can see that option D is the correct answer because it is the answer that we got after, applying force due to a conductor, due to two parallel conductors. So therefore option D is the correct option for this question asked in 2017. That concludes this episode of NEET JEE Main. If you want to access more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. We also have a lot of videos on the playlist NEET JEE Main. If you want to access those, then you can hit the link for the playlist in the description box down below. To get updates on our latest content, don't forget to hit the notifications button, again present down the video. So until the next episode, take care, stay safe, bye-bye for now.